Hello everyone. So in today's video I want to review two topics with you. One is how we work with some algebraic skills, and then the second skill we'll look at is how we use those skills to help us solve equations. So our first example here, I'm just going to run through a number of examples with you to show you some of these skills. We have to remember that when we have this number that is sitting in front of the bracket, that the operation between the 3 and the bracket is an implied multiplication. And since we are multiplying it by a binomial, remember binomial means that we have two terms here, terms separated by addition or subtraction, that we're going to take this 3 and we're going to distribute that to both of these numbers. And that's where it gets its name. We actually call this the distributive property. So if we use that distributive property, okay, remember with algebra, we put our equal sign at the beginning of the line. As we distribute that, we're going to multiply the 3 by each of those terms. So 3 times the 2x. Remember, we're going to multiply the 3 with the coefficient. That'll give us 6x. And we're going to multiply the 3. And when we have our terms, we usually consider the operation as the sign or part of that second term. So I'm going to say 3 times negative 5 gives us negative 15, or we can think of that as 3 subtract 5. When I multiply the 3 with the 5, we're now subtracting 15. Likewise here, we can distribute in our second example. The only difference here is this time we are distributing 5x. So we're distributing an algebraic term instead of just a number. We use the same rule. I'm going to take that 5x and I'm going to multiply it by both of these terms that are inside the bracket. The part here that we need to remember is that if I take 5x and I multiply it by 4x, we will multiply their coefficients. That'll give us 20, but we also have x times x. And x times x, algebraically, we would write that as x squared. We would do the same thing with the second term, 5x times negative 7. I would multiply the coefficients, or the number parts, which will give us negative 35. I have the x, but I'm multiplying it here. There are no more x's, so that x just gets carried along. And there's our expanded, simplified expression. Here, same idea, just adding one more small piece. We got to be careful now that the number is now negative. We also still have the x. This time we have 3 terms. Reminder that if I have 3 terms, this would be called then a trinomial with 3 terms. So we are now going to distribute this to all 3 of those terms. As we do that, we will end up here then multiplying coefficients. Be careful with our signs now. This is negative 8 as I multiply those together. X times x squared. So if I already have an x squared and I multiply it by another x, we would now have x cubed. Remember, this is saying we're multiplying 3 x's together, x times x times x, which is what we've done, x times x times x. My next term, this is where we really have to be careful with these signs. Negative times negative will make this a positive. 2 times 3 gives us 6, and x times x gives us x squared. Last term, negative times negative gives us a positive. 2 times 5 gives us 10, x, and we're multiplying, there's no more x's, so that x just gets carried along. So in all 3 of these examples, we call this our distributive property and just slight variations of what that looks like. Now what we'll do is we'll bump that up and we'll say, well, what if I now make my expression a little bit larger? So now I have to use this distributive property, but 2 times. Here I'm going to distribute the 2 into its bracket, or that first bracket. And then here we're also going to add on. So I'm going to say I'm taking positive 5. Again, the sign stays with that term. And I'm going to distribute that into the second bracket. So if I distribute now both of these, I'm going to get 8x minus 4. Here I'm going to get 15x plus 10. Now, in this case, we are not done, because now, if you remember from last year, we have to simplify this further because we have like terms. Remember, like terms are those terms that have the same variables. So those would both be like terms since they both have an x. Remember that as we do this, again, whatever sign is with that term, that goes with this. So as I collect these together, I have 8x, and I'm going to add on 15x. Remember, we collect like terms by adding their coefficients. So this would give us 23x. Notice that unlike multiplying, the variable stays the same. We're collecting x's together. I have 8 of them here. I'm adding 15 more of them here, so I have 23 x's. With the second part, we have to be a little bit careful because as I collect this together, I'm going to have -4, so we have to pay attention to that sign, and I can collect that together with +10. -4 plus 10, again, remember with integers, think of your number line, or if you need to, use a calculator. If I'm at -4 and I add 10, we will end up at +6. And there's our simplified expression. Remember that these cannot be collected together since they are not like terms. They do not have the same variable. This one has an x and this one does not. And if you go back and you look at the original 3 simplified polynomials that we created, you'll realize that we couldn't simplify these any further either because none of them had like terms. This had an x, this one did not. This one had an x squared, this one had an x. These are not the same. They have to have the same variable with the same exponent to be like terms. And the same thing with our third one. This one had an x cubed, this one had an x squared, this one had an x. So they were all different terms, so we could not collect them together. If we continue then with this idea of expanding out the brackets and then simplifying or collecting our like terms, okay, same idea in this example. Again, we've just upped this because now we're going to multiply by a variable. So I distribute that into that first bracket. Here we're going to have to be very careful. Not only do we have that variable, but we have that negative here that gets attached to that term when I distribute it into that second bracket. As we do that, then, if I distribute, same as what we were doing up above, okay, multiply the coefficients, multiply the variables. Same thing with our next term. Multiply the coefficients. There's no more variables, so the x just gets carried along. Here, be careful with that negative. We end up with -8x squared. And then negative times negative, be careful that we end up with a +2x. Again, as we expand out, notice that we do drop the brackets, or we lose the brackets as we expand out those brackets. Collecting our like terms, in this case I have x squared, so I have 24x squared, and I'm going to subtract off 8x squared. So we will get 16x squared, and then I have a +20x and a +2x, so that will collect together to give us 22x. The last one looks actually simpler than these two. I just want to quickly review what happens if we have brackets and there are no numbers out front. One way you can think of this is that you can kind of think that there's always a number there. If there's not one written, we can always think of that as just being a 1. So we can always think of this as distributing that 1. So if I distribute a 1, essentially nothing is going to change other than we will now drop the brackets because we have multiplied those brackets out, or we have distributed. So 1 times 9x, 1 times -7, they stay the same, but no brackets. Second one, we do have to be a little bit careful because we are multiplying not just by 1, but by -1. So as I expand out that second bracket, we will end up with -3x. Most students will catch that fine, but this will be the one where some students will get caught. Be really careful. -1 times a -5, we end up with +5. Collecting our like terms, we have 9x minus 3x is 6x. -7 plus 5 gives us -2. Hopefully as we went through that, some of those skills coming back to mind. There will be some practice for you to try here when you're done looking through the note. Okay. The other skill that I want to look at then is using some of this algebra to solve equations. Remember the difference between an expression and an equation as we compare these two is that an equation will have both a left and a right-hand side. We think of this kind of like a balance where we're saying the left side is equal to the right side. And our goal is to figure out, well, what number would we put in here for x to make these two sides balanced? Some equations are very simple and you could almost do them by guessing. But if you remember from last year in grade 9, we showed you a set of rules that we can use to solve these equations. So what I want to do here is remind you that when we're solving equations, my goal is to get the variable all by itself. In other words, I want to get rid of the adding 7. So last year we would have done something like this. We would have said if I have x plus 7 and I want to get rid of that 7, then we talked a lot about using opposite operations. The opposite of adding 7 would be to subtract 7. And then, because these two sides are equal, if I'm subtracting 7 on the left-hand side, then I also must subtract 7 on the right-hand side. If we simplify both sides, the left side becomes x, and the right side becomes 8. And we see that x equals 8. And we can always go back and check, does that make sense? 8 plus 7, if I sub the 8 in, is equal to 15, so we know we have the right answer. So if we go through a number of operations here, this one I've just switched the x to the right-hand side. Again, it doesn't matter if the x is on the left or the right. I'm still going to use this idea of opposite operations. So if I have x minus 6, I'm trying to get the x by itself. The opposite of subtracting 6 would be to add 6. So if I add 6 on the right-hand side, then I'm also going to add 6 on the left-hand side. And if I do that, the left-hand side becomes 19, and excuse me, the right-hand side becomes x. And again, we can check, does that make sense? 19 minus 6 would be 13, so we are getting the right answer. Here we have multiplication. Remember, when we have a number next to a variable, that is called implied multiplication. So the opposite of multiplying would be to divide. This one is very easy to write. We don't necessarily have to rewrite a whole line, but I'm going to write the opposite of multiplying is to divide, and I'm going to use my fraction division to do this. On this side, the 5s will divide out. I will end up with 1. Remember, as a coefficient, I don't have to write coefficient 1, so we have isolated the x here. And if I divide on the right-hand side, we end up with 7. And again, we can check, does this make sense? If x is 7, 5 times 7 is 35. One that we don't see very often, but is still this idea of opposite operations, is this one here. X over 4 equals 5. Remember, when we write this idea as a fraction, that this is just division, and the opposite of division would be to multiply. So we can still use our opposite operation idea here. The opposite of dividing by 4 would be to multiply. And again, with an equation, we're going to do the same operation to both sides. So if I do that, we would end up with here 4x over 4, or those 4's would divide out. And 5 times 4 gives us 20. Again, checking, 20 divided by 4 gives us 5. Last year, I'm sure your grade 9 teacher was often getting you to write in what operation you were using. What is that opposite operation that you did in each line? As we move to grade 10, we want to try to streamline things a little bit as questions get more complex. We don't want to have to write out and show our reader every single step. So we would like to be able to now jump from this line to this line here. And maybe your grade 9 teacher was letting you do that last year, maybe not, but in grade 10, I'm going to start to jump and say, well, we're going to think about those lines that I've put in there in red. I'm going to do that more in my head and just write the next line. So for example, as we work on this fifth example here, this time we have two things to get rid of. It's sort of like, excuse me, using the reverse of Bedmus. Whatever the coefficient is on the variable, that will be the last thing that we will get rid of. So what I'm going to focus on right now is how do I get rid of the adding 3. So to get rid of adding 3, I'm sort of thinking, and I'm just going to write it just this time very lightly up above. I'm sort of just thinking this step here. I'm going to subtract 3 from both sides. Okay, so as I do that, I end up with 4x here. And if I subtract 3 on this side, I end up with 20. 4x equals 20. And then I'm thinking, okay, next I need to get rid of multiplying by 4. So to get rid of multiplying by 4, okay, the opposite would be to divide by 4. So if I divide by 4 here, I'm just thinking it, I'm not going to write it, I would get x. So if I divide by 4 here, I get 5. So we don't necessarily have to show every single step as we work through this. Okay. Our next one, we actually bump up here a little bit in our equation. Notice what is happening is that I now have x's on both sides of the equation. So my first step here is, like all these previous questions, I want x's to be on only one side of the equation. So to do that, again, we use this idea of opposite operations. If I am subtracting 2x over here, what I can do is just add 2x to both sides. If I add 2x, the opposite of subtracting is to add, I'm going to get rid of that whole term. So I'm not trying to get rid of just a 2, I'm trying to get rid of the whole term now. And if I do that, 8x plus 2x will give us 10x plus 6 equals 36. And now we're back to an equation like what we were here. We have all our x's collected on one side. So now to try and isolate that x, I'm going to get rid of the adding 6. So the opposite of adding 6 would be subtract 6. I'm not going to write it. I'm just going to go ahead and do it. Subtract off 6 here. I'm left with just the 10x. So subtract off 6 on the right-hand side, and I'd be left with 30. Now I'm multiplying x by 10. The opposite would be to divide by 10. That will give me x. So if I divide by 10 here, I am left with 3. If you're still feeling more comfortable with putting in the extra lines, feel free to do that. In some of these cases, I've started to scribble a little bit of my rough work up above, sort of a transition between writing it out formally and just kind of informally showing a bit of my thinking, and then moving forward to not writing anything at all. So wherever you're at, you can put those pieces in, but we want to try to work towards is that we don't necessarily need to show all of our steps as we do that. Okay. A few more examples. I'm going to flip to a second page here. Okay. In this example here, then we've added just one more layer. This time we have to simplify both sides first. Okay, so if I simplify, now we can start to use our algebraic skills, our distributive property. So I'm going to expand out those brackets first so that I have 6x minus 12 equals 4x plus 16. So there's my first step, is to simplify or expand the left right-hand side. If I have x's on both sides, my next step is I always want to collect all the x's to one side of the equation. Again, if I have 4x on this side, to get rid of that, I am going to subtract off the 4x. So if I subtract it off on the right-hand side, I also have to subtract it off on the left-hand side. So if I do that from both sides, we will have 2x minus 12 is 16. Now I have a single x, so if I'm trying to isolate that, to get rid of the subtracting 12, the opposite would be to add 12. So if I add 12 here, that's gone. If I add 12 here, that's 28. My last step, I'm multiplying x by 2, so my opposite operation, divide this side by 2, gives me x. So same operation here, divide the right side by 2, and we end up with 14. So there is our solving without showing necessarily all those in-between steps. Last two equations here deal with equations that have fractions. And there's a few ways we can tackle this. Your grade 9 teacher may have showed you a few different ways you can do this. The way I'm going to suggest that we tackle this is by looking at the denominators. We want to really get rid of these fractions, and that'll make these equations a whole lot easier to solve. So if I look at the denominators here, what I realize is that I have a common denominator. My common denominator for 6, 2, and 3, my common denominator would be 6. So what I'm going to do with that is I'm actually going to go ahead, I'm not going to get a common denominator for each of these fractions, but what I'm going to do is I'm going to take each of these individual terms and I'm going to multiply them by that common denominator. So I'm going to do 6 times 2/3 x. I'm going to do 6 times 5 over 2. And I'm going to do 6 times 1/6. Remember, as long as we do the same thing to both sides, we haven't changed the equation. So I have multiplied all the terms on the left side by 6, and I've multiplied the one term on the right by 6. We've done the same operation to both sides, meaning that the equation is still the same as this one, just looks a little bit more complex because we have all those 6's. The nice part is that if we multiply by a common denominator, something nice is going to happen here. If I take this number and I now multiply it into the bracket, what we do is we multiply it by the numerator. So I do 6 times 2, and then I'm dividing by 3. 6 times 2 is 12, divided by 3 is 4x. We've picked a number here that when I multiply this and divide by 3, I'm going to get a nice number. The same thing happens with that second term. If I do 6 times 5, I get 30, divided by 2 is 15. And my last term, if I do 6 times 1, I get 6, divided by 6 is 1. So multiplying by that common denominator has now allowed us to get rid of these fractions. We picked a number that will work nicely when I'm dividing by 3 or by 2 or by 6. When I multiply and divide, we get nice numbers here. Now we're right back to where we were solving any of our other equations. I'm trying to isolate the x. To get rid of adding 15, I'm going to subtract 15. That'll give me 4x. If If I do that on the left side though, I also need to do that on the right side. So if I subtract 15 here, I'm also now subtracting 15 on this side. 1 minus 15 would be negative 14. And if you need to use your calculator, again, you can go ahead and do that. Now, in this question, we might say, well, when we divide by 4, we don't get a nice number. That's fine. I'm going to go back and I'm going to put this in here. Okay, there's our dividing by 4. The left-hand side, we get x. The right-hand side, if it doesn't divide nicely, remember we can always leave this answer as a fraction, but we are going to reduce it to lowest terms. 14 and 4 are both divisible by 2, so we will reduce that fraction to its lowest terms, and we can leave our final answer as a fraction. In our last question here then, we still have some fractions. This time looks a little bit more complex because I have a binomial, 2 terms in our numerator, but we can apply the same skill that we did here to this question as well. If I look at my denominators, okay, 3 and 5, I'm going to say my common denominator for these is 15. So I'm going to multiply then both of the fractions here by 15. So I'm going to do 15 and, oops, not 3, 2, x minus 1 over 3. And I can do the same thing here. I have 15 and I have x plus 2 over 5. Okay. If we want, we can go ahead and multiply this in. This would give me 30x minus 15 all over 3. Last time we multiplied and divided all at the same time. This time I'm going to do it in 2 steps only because here there's a little bit more work as we multiply this out. So 15 times 2 gives us our 30, 15 times 1. Okay, here we would have then 15x plus 30 over 5. Now we can go ahead and divide. The only difference is because I have a binomial, I have to make sure that I divide this into both of these terms. Okay, and some of you might feel comfortable doing that all in one step once you see what we are doing. That's fine, you can go ahead and do that. If you don't, then we can do this in 2 steps. As I divide, I get 10x minus 5. Okay, the 3 has to divide into both terms, and I can do the same thing here. I'm going to end up with 3x and 6 as we divide that out. We're now back to that equation, and again, this is where you have to decide where are we at. We're at a point here where I have x's on both sides. So my first step is to collect all the x's to one side of the equation. To get rid of 3x, I'm going to subtract it off on this side here. So if I do that, I'm left with just 6. If I subtract a 3x here, then I also need to subtract a 3x on the left-hand side. 10x minus 3x gives us 7x minus 5. Isolating the x, I'm going to get rid of the subtract 5. The opposite of subtracting 5 would be to add 5. So if I add 5 on this side here, we get 11. Lastly, the opposite of multiplying by 7 would be to divide by 7. That doesn't divide nicely, so I'm just going to leave it as a fraction. And in this case, it doesn't reduce. So I'm going to leave that then as my final answer. I hope that helps. If you have any questions, make sure that you are emailing me. If not, there is some practice that is attached to our assignment. You can go ahead and try those practice questions. Have a good day, guys.